I'm Jared Hyman, an assistant professor of chemistry at Elon University. Today, I'll be taking you through the appropriate technique and procedure for preparing a chemical solution. One of the most important abilities at all levels of chemistry is the preparing of a solution of a specific concentration. First, we'll define some of the terms used in this process. A solution is a homogeneous mixture of two or more chemicals. For the simplest solution, a smaller amount of one chemical, called the solute, is placed in a larger amount of a second chemical, known as the solvent. Today, we will be preparing a solution of sodium chloride, using a small amount of sodium chloride as our solute, added to a larger volume of water, our solvent. Before beginning any experiment, it's important to observe appropriate lab safety procedure and know the hazards of any chemicals you're working with. In any chemical reaction, it's important to keep track of the exact amount of reactants present, and for stoichiometric purposes, we use the term mole to define the amount of a substance. A mole is a counting term, similar to a dozen eggs, where 1 mole is equal to 6.022 times 10 to the 23rd things. As you can see, this is a really large number. The periodic table uses molar counting as a means of converting to a more experimental term of mass. For example, 1 mole of carbon atoms has a mass of 12.01 grams. In a compound such as sodium chloride, it's made up of 1 mole of sodium atoms with a mass of 22.98 grams per mole, along with 1 mole of chlorine atoms with a mass of 35.45 grams per mole, giving us a total of 58.43 grams per mole of sodium chloride. This means of using mass to determine the amount of a substance is useful for pure chemicals. But in the case of solutions, we now have a mixture of multiple different substances. Therefore, we express amount as a concentration. The most common unit for concentration in chemistry is molarity, abbreviated capital M, which indicates the number of moles of solute dissolved in a certain volume of the total solution. This gives molarity derived units of moles per liter. It is very important to note that this is a volume of solution, not the volume of solvent. Today, we will be preparing 500 milliliters of a 0.25 molar sodium chloride solution. Before beginning, it's important to map out your procedure for preparing this solution. Here, we'll look at the amount of sodium chloride we need in this solution. We know that we want to prepare a 0.25 molar solution, which means that there is 0.25 moles per liter of solution. We also know that we only want 500 milliliters of this solution, or a half liter. If we multiply these two terms together, we can see that we will need 0.125 moles of sodium chloride. From earlier, we can remember that there are 58.43 grams per mole of sodium chloride. We can determine that the exact mass that must be measured out is 7.304 grams of sodium chloride. In lab, obtain some sodium chloride in a clean lab scoop, and using a balance with some weighing paper, measure out as close to 7.304 grams as possible, marking down your exact mass. Note that if you go over the desired mass, it's never appropriate laboratory procedure to put the excess reagent back into the original container. Always use an additional container to collect the excess. Once you've measured out your solid and recorded the exact mass, transfer all of the solid to the appropriate sized volumetric flask. Volumetric flasks are made specifically for this purpose and should be used over other less accurate labware, such as beakers, Erlenmeyer flasks, or graduated cylinders. Here, we just transferred our solute to the 500 milliliter volumetric flask. If any solute remains on the weighing paper, use a spatula or a small amount of water to transfer the remaining salt. Next, add enough water so that the bulb area at the bottom of the flask is approximately half full. This will give you enough room to swirl the liquid, allowing the solute to completely dissolve. Again, it's critical that all of the solute is dissolved prior to filling to the appropriate volume, as different solutes may take up more volume in solution than their undissolved salts. Now that the sodium chloride is completely dissolved, we can fill the rest of the bulb area and some of the neck with water. You should now carefully and slowly add water, our solvent, as it begins to fill the neck. Once you approach the etched or printed line on the neck of the flask, you should add solvent dropwise, monitoring the location of the meniscus. Water, as a polar solvent, tends to cling to the glass walls of a flask. This phenomenon creates what is called a meniscus. The bottom of this curved meniscus should sit directly level with the line on the flask. At this point, there is exactly 500 milliliters of solution with an air of 0.2 milliliters. Different volume flasks have different air values. However, the air on a volumetric flask is much lower than any other type of glassware of similar volume. For example, the volume markings on a beaker or an Erlenmeyer flask are only accurate to plus or minus 5%, meaning if the meniscus were on the 500 milliliter line, it could be anywhere between 475 milliliters and 525 milliliters. On the other hand, using a volumetric flask, we know that the volume is exactly somewhere between 499.8 milliliters and 500.2 milliliters, meaning it's much more accurate. We now must determine the exact concentration of our solution by taking the mass that we measured out and dividing by formula mass for sodium chloride, 58.43 grams per mole, which gives us a total number of moles in our solution of 0.1253 moles. We can then take this number and divide by our volume of 0.5000 liters to give us a total exact concentration of this solution of 0.2501 molar sodium chloride. This value and the contents of the solution should be clearly labeled on the chosen storage container for laboratory safety protocol. You've now learned how to make a solution from a solid. Everything you need to do this demonstration in your lab is available from Carolina. We have experts who can assist you with any of your science demonstration needs. Visit us at carolinachemistry.com to see our complete line of products and kits for chemistry.